All right, we're gonna get started. Really, today is all about reviewing what we did last class, which is the law of sines. Okay, I'm looking over questions in on campus and your scores in IXL, uh, and some people haven't even attempted it. Uh, so I'm gonna give you guys another like 2 minutes or so to actually come up with a question because I know for a fact there are questions out there, uh, and that's what this class is gonna be about. I have a bunch of examples already. Um, but it's better if it comes from you. All right. So take 30 seconds, take a minute or two, go to IXL, and if you have a problem with one of them, screenshot it, email it to me, and we can go over it. Okay. This doesn't work if we don't attempt this stuff before class actually starts. All right. So that needs to happen. So again, take a minute or two, grab a question, and then you can email me or put it in the discussion board. Okay. Um, so just as to start, and if you're still trying to find a question, that's fine. Just to start, what we went over last class is the law of sines. Okay. So what the law of sines has to do with are triangles that are not right triangles. Okay. So if you have a triangle that does not have a right angle in it, we can find side lengths, and angles using this formula, which is basically just setting up a proportion with an angle and its opposite side. And those are always going to be proportional to every other angle and its opposite side. Okay, that's what we did. That is the equation. If we know the equation and you're able to do a little bit of algebra and maybe a little bit of work on your calculator, this shouldn't have been too difficult. Okay, so I want to go over a couple of questions. And I'm not going to start on this one. I'm going to start on something different. So give me 2 seconds. So in this problem, we are given this figure, and we're trying to find g. So we're trying to find this side length. All right, it says write your answer as an integer or as a decimal rounded to the nearest tenth. Okay, so we got to do some groundwork before we do calculator work, but we can set up our formula using our law. So if we just set that up, we know that the sine of g, the sine of angle g over its side length, is equal to the sine of angle f and its opposite side length, and the sine of angle e and its opposite side length. All right, so sine of g, this angle, its opposite side length, sine of angle f, and its opposite side length, and then angle e with its opposite side length. Okay, so that we need to be able to do that. We need to be able to locate opposite sides and set up this proportion. And if we're able to do that, and a little bit of calculator work, again, this shouldn't be very, very difficult. Okay, so then we just substitute in what we know. So sine of g is really sine of 13. G is unknown. Angle f is 17. Its opposite side length is 14. And then we don't know anything about e. Yes, this is the problem you sent me. All right, so once we have that, we got to think about what we're trying to find and what we have. Okay, so since we're trying to find g, this g should be our only unknown. So we need to cancel out anything else with an unknown in it. So we get rid of our angle e and our opposite side e because we don't know anything about it. Okay, then we can do a little bit of algebra first. So if we cross multiply and we solve this proportion, we would get that 14 times sine of 13 is equal to g times sine of 17. And again, we're trying to get g by itself. So if we divide both sides by sine of 17, we get g is equal to 14 sine of 13 divided by sine of 17. And that would be our answer. Okay, so before we go to a calculator, are there any questions about how I set that up? All right, then in order to actually get the answer, you can go to Desmos or you can go to your TI-84, TI-83 and type in basically what I have right here. All right, now I would always type it in as parentheses around the numerator and parentheses around the denominator. And if you do that, everything should turn out just fine. Okay, I'm confused why you mixed them together like that. That's just algebra, right? So all we're doing right there is cross multiplying. Right, so we multiply g on both sides, and we multiply 14 on both sides. That's solving a proportion. Okay, then we can type that into Desmos. Again, we need to make sure we're in degrees. So we go to our wrench icon, go down to degrees, click it, and then we'll be in the right zone, or right mode. Okay, then we just type in what we have. So 14 times sine of 13 divided by sine of 17. And we get 10.77. This says round to the nearest tenth. Okay, so our answer would then be 10.8. And that is the length of that G side. Okay, on your like TI-84 or TI-83 calculator, again, we would just type in, first we need to check that our mode is right. So we hit the mode button, scroll down to where it says radian and degree, highlight degree, hit enter. And then I always have parentheses, 14, and then I basically just type it in exactly as I have it up on screen. Sine of 13 divided by sine of 17. And you get the same answer. Okay, if you need to do that in steps 2, that's fine. Okay, but questions about that problem? All right, so I want to do a couple more examples. These are not from iExcel, so I actually created a kind of a worksheet, which is you can find it on campus. It's in that right triangle trig topic, and it's the last thing. It says law of sines review, or it has law of sines in the title. Okay, so if you want a couple of different examples, that is the best place to get some. So the first thing is this example right here, right? So we're given a triangle ABC with an angle 58 and two side lengths 26 and 28. And we're trying to find the measure of angle C. Okay, so given this diagram, the first thing we should do is to just find which sides are opposite, right? So angle C has an opposite side length of 26. Angle A has an opposite side length of 28. Okay, so then we can set up our law of sines and solve for that angle C. So when we do that, we would get that the sine of A over its opposite side length is equal to the sine of angle C over its opposite side length. Okay, and we don't need to worry about angle B because we don't know anything about that angle or its opposite side. So we're just going to ignore that because we can only have one unknown, and because we don't know angle B or its opposite side length, we don't need to worry about it. All right, so when we solve for this, we want to solve for angle C. Okay, so really all we need to do is multiply by 26. So when we do that, we get 26 sine of A over 28 is equal to the sine of C. Yes, sine of A is 58. I didn't even see those on IXL. That's okay. We're doing them. They're just examples. It's with the same topic. It's actually just adding one more, like a little step that's kind of tying into what we did before, which is inverse trig. Okay, so when we're trying to find the angle, and it's inside of a sine, right? So we're trying to find this angle C. In order to get that C by itself, we have to take the inverse sine of both sides. Okay, so what that'll look like is sine inverse of everything on the left-hand side is equal to, and when we take the inverse sine of sine, we're just left with what's inside. So this will just be equal to C. So then again, we go to Desmos, or we go to our calculator and type in what we have on the left-hand side. Again, I would put parentheses around the numerator and around the denominator, and then everything should be fine. Okay, so if we start to type that in to Desmos, we want the inverse sine, and then we type in parentheses 26 times sine of 58. Divided by just 28. And when we do that, we get 51.95. Okay, and again, I think that this is a question that says round to the nearest tenth, so that would round up to 52. Okay, questions about that example, because that ties in a couple of things that we haven't done in a little bit, mainly inverse trig. All right, next example I want to go over is a little bit more kind of like IXO, what they did. again, we need to know both ways. So the ones that we did on IXL is very much like this, but it shouldn't be much of a problem to go that one step further, which was the last example. All right, but given this triangle, given triangle ABC, we want to find the measure of AC. Okay, so we want to find the measure of this side. And because it's not a right triangle, we're going to end up having to use the law of sines. So we have only one side length. So we're going to start there. So when we start with the side length, we have to figure out what its opposite angle is. And because we have this side length, its opposite angle ends up being angle C. But we don't know that right off the bat. However, we can find it because we're given two other angles, right? 88 and 27. So if we add up all these angles together, if you add up angles of a triangle, you always get 180. So when we do that, 88 plus 27, that's 115. So then angle C is 65. Okay, so that's step one, is just to find this opposite angle. Then once we do that, we have an angle, its opposite side, and we're trying to find another angle's opposite side, which we already have. Okay, so then again, when we set up our law of sines, we get sine of C over its opposite side length is equal to sine of B over its opposite side length, which I will call this side B. All right, then we can just replace what we have in. So the sine of C is really sine of 65. Its opposite side length is 10. Sine of B is really sine of 27. Its opposite side length is unknown. Okay, so then we solve for that unknown by cross multiplying. When we do that, we get B times sine of 65 is equal to 10 times sine of 27. Then we divide on both sides by sine of 65. So we get B is equal to 10 times sine of 27 divided by sine of 65. Questions about how I set that up? Then we can type that into a calculator. So we want 10 times sine of 27 divided by sine of 65. And we end up getting 5.009. Again, this says round to the nearest tenth. So you just get 5, which is that side length B. Okay, questions about this problem, questions about this concept. This is the time to ask, okay? I will give you like this class period to kind of finish this IXL, but questions right now would be great. Okay, and before we kind of end this, um, keep in mind that this only works. This learning only works if people actually ask questions. It's really hard uh, to understand whether or not people get it unless they've actually tried the homework uh, and or are asking questions about it. Okay, so there's a lot of people that haven't even attempted the homework yet, which it doesn't help. Okay, you had an entire weekend plus Friday, like to at least attempt it. Like I'm okay not getting 100 on it right away, but there has to be some kind of like at least attempt in order to do it. All right, and some people will be receiving emails just because they haven't attempted any homework in the last like 3 weeks, um, but that's it. It has to happen. Okay. So I'm gonna leave this open for the next 2 or 3 minutes, and then I'll start a meeting on Teams. Um, and if you have any general questions about these problems, please ask. There are also a bunch of example problems in On Campus. It's in that right triangle trig topic, and it's law of sines. Okay, there's 20 examples. The first 10 are like the first one we did. The second 10 are like the second ones we did. Okay, and then there's always IXL. Okay, but we need to actually attempt this stuff in order to actually understand it. This will be a part of the project. So the more you understand it now, the better it'll work later. What is the homework? The homework is to finish this IXL. Uh, it's yeah, that's what you got to do. So if you haven't gotten 100 on it, get it to 100. Even if you're at like 95 or whatever, like get it to 100 because you have time. Yeah, it's R11. I was mixing you up with my seniors. Okay, so I'm going to close this. I'll start a meeting on Teams. If you haven't attempted this or are struggling with it, I kind of expect you to be in there. Um, that again, that needs to happen. That's part of the class. Okay, so I'll close this and I will see you on Teams in the next like minute or so.